This is Euclid Book 10, proposition number 52. And now we're going to find a fifth binomial straight line. Let two numbers AC, CB, well here's AC right here and here's CB right there, be set out such that AB has not to either of them, okay, the ratio which a square number has to a square number. So, as this is to this, it is not a square number to a square number. As this is to this, it is not a square number is to a square number. Okay. Let any rational straight line D be set out. Well, there it is. And let EF be commensurable with D. So this length right here is commensurable with that. Therefore, EF is rational. This length is rational. Let it be contrived that as AC is to AB, as this is to this, so is the square on EF to the square on FG. Where did we get these squares? Okay, we took EF right here, we made it into a square, so all four sides of that square are going to be the length of EF. Same thing here, we took the length of FG, we made it into a square, so all four sides of this square are going to be the length of FG. Okay. So as AC is to AB, so is this is to this. This is by Euclid Book 10, proposition number 6, porism. But AC has not to AB. AC does not have to AB the ratio which a square number has to a square number. Therefore, neither has the square on EF to the square on FG the ratio which a square number has to a square number. Therefore, EF and FG, these two squares right here, or actually, correction, these two lines right here, therefore EF and FG, the lines, are rational straight lines, and they are only commensurable when they're squared. This is by Euclid Book 10, proposition number 9. Therefore, EG is a binomial. This length right here is a binomial. This is by Euclid Book 10, proposition number 36. I say next that it is also a fifth binomial straight line. For since as AC is to AB, as this is to all of this length right here, so is the square on EF to the square on FG. As this is to this, so is this is to that. Inversely, as AB here is to AC here, so is this is to this. Therefore, the square on this line right here, which is this right here, this has more area than this. How much more area does this have to this? Well, we're going to find out, because we're going to draw this line right here. This is line H, and we're going to make a square out of it. Okay, so all four sides of this square are going to be the length of H. Okay, so now we're going to add this area here and this area here together, and when we do, we're going to get this area right here. Therefore, convertendo, as AB is to BC, so is this is to this. Okay? So let's say that again. As this length right here is to this length right here, so this area is to this area. This is by Euclid Book 5, proposition number 19, porism. But AB has not to BC. This does not have to this a square number to a square number. Therefore, neither does the square on FG have to H a square number which is to a square number. Therefore, the length of FG right here is incommensurable with the length of H. This is by Euclid Book 10, proposition number 9. So if the square on FG, this one right here, is greater than the square on this, okay, so this area is going to be bigger than this area, by a square on a straight line incommensurable with FG. Okay, so this is bigger than this by this area right here, and this area, if you turn it back into a line, is going to be incommensurable with this. Okay. Now, EF and FG, both of these lines here, okay, are rational straight lines. They are only commensurable in square. This line is not commensurable with this, but this area is commensurable with that. And the lesser one, which is this one right here, is commensurable. Okay, this length right here, okay, this length is commensurable with this. Therefore, EG, this whole length right here, is a fifth binomial straight line. Wow. Alright. I will tell you more in a future video, so I want you to stay tuned.